So question 9, we can solve this equation. So again, our strategy is, looking at the problem, it's got some decimals involved here, but if we look at simplifying each side of the equation, we don't see any parentheses. And again, there's not really any like terms on either side. Fractions aren't present, but notice how decimals are present. So what we can do is multiply by the appropriate number of tens to remove the decimal. This may require parentheses and distributive properties. So remember, multiplying by 10 moves the decimal one place to the right. Multiplying by 100 would move the decimal two places. So again, whole numbers are decimals, but the decimals is on the end and it isn't shown. So remember, a whole number can be represented as a decimal, they just don't show it. So like if I give you the number 10, 10 is actually 10.0 if I wanted to put a decimal there. So keep that in mind. Whole numbers are decimals. We just don't show the decimal. So anyway, notice how we have to move the decimal one place to the right. If I do, then these are now going to be whole numbers. So to make a decimal move one place to the right, all we got to do is multiply by 110. So to do this math, we want to multiply each side by 10. So 10, and then we have this 0.9t here. And then on the other side, we have 10 in parentheses, 0.7 plus 0.4t. So again, the distributive property really isn't necessary on the left side because it's just 10 times 0.9t. But remember, when you multiply 10 times 0.9, the decimal is going to move one place to the right. That turns into 9t. On this other side, 10 times 0.7, it's going to make the decimal move one to the place to the right. That's going to be a 7. And then 10 times 0.4t, again, the decimal is going to move one place to the right and turn it into 4t. So by multiplying each side by tens allows me to remove decimals. That's the cool thing about the property of equality is you don't actually have to deal with decimals if you don't want to because of that. So we've done that. We don't have any like terms. So again, notice how if the variables on both sides, we want to pick on the little guy. So notice how there's a 9t on the left side and there's a 4t on the right side. So to me, the little guy is the 4t. So I want to subtract a 4t here. I want to zero it out, but I have to subtract a 4t over here as well to keep it balanced. So 9t lose 4t is going to be a 5t. And then the 7 comes down over here, and the 4t and the negative 4t will zero out. So notice how we don't have a constant, all we have is a coefficient. To make the coefficient go away, we just got to divide by the coefficient. So if we divide by 5 here, we have to divide by 5 over here. So this gives us then, so t is going to equal then this 7/5. Now let's see if they want a decimal or a fraction here since we have decimals. So simplify your answer. So it doesn't say anything about having to have fractions. So your answer can be a fraction or a decimal. Let's see. Start with that. Okay. So I can leave it as 7/5 or a decimal on this one. So 7 divided by 5 would be 1.4. So to me, since the answer's got decimals in it, it would make sense to me to turn it to 1.4. So try that. See if it'll actually take a decimal as well. If it doesn't take the decimal, then we have to go back to the 7/5. So I'm going to check it by just substituting the 1.4 in for t. So if I check it, I should have 0.9 times then 1.4. That's going to give me 1.26. On the left side, I have this 0.7 plus 0.4 times 1.4. So I'm going to replace t with 1.4. And notice how it does give me 1.26. So that would be the solution. So since it says simplify the answer, I think it should accept decimals as well there. So I would say you could also put 1.4. But if it doesn't take the 1.4, just keep that in mind and leave it as the 7/5.